In this lesson, we're going to learn how to move our graph around our coordinate axis by either moving it left, right, up, down, stretching or compressing it, or reflecting it across our x-axis. And we're not actually going to do any of the graphs. We're just going to identify the transformations being applied to our logarithmic function. So I want you to go ahead and pause the video and take your notes down of how to interpret all of the transformations being applied to a log function. Alright, so now that you have your notes down, let's take a look at them. If you add or subtract a number inside the logarithm with the x, you're moving your logarithmic graph left to right. And in the last video, you noticed that we had a vertical asymptote at x equals 0. And if you move that graph left to right, you're going to be moving your vertical asymptote left to right with your graph. Alright, so now what happens if you add or subtract a number outside of the logarithm? Because this is your logarithm right here. You can pretend that there's parentheses around this log and around the x, and that h is being added or subtracted from the actual logarithm. That moves your graph up or down. Then if you multiply your logarithmic function by a number in front, you're either going to stretch or compress it. And then if it's negative, you're going to reflect it across the x-axis. So the very first thing I would do is I'd check to see if we're doing a reflection. If we're doing a reflection, that means it's going to flip your logarithm graph over the x-axis. Then I would take a and take its absolute value. And if that absolute value is greater than 1, it's a stretch. If it's somewhere in between 0 and 1, then we're compressing. So let's take a look at 4 of these functions here, and let's just describe the transformations being done. Well, the number in front is 5 of our logarithm. So let's go ahead and take a look at this case. If our number in front, the absolute value, is greater than 1, it's a stretch. So we're stretching this by a factor of 5. So it's a stretch by 5. We're not adding or subtracting anything to our x before we take our logarithm, and we're not adding or subtracting anything after we take the logarithm, so this is the only transformation. So in example number 2, let's start with the number in front. We have a negative in front, a negative number 1. And if we come over here, if we have a negative, if a is less than 0, we are reflecting it across the x-axis. So this is a reflection across the x-axis. Alright, so this is a negative 1. If we take the absolute value, it is 1. 1 is not greater than 1, so it's not a stretch, and 1 is not between 0 and 1, so it's not a compress. So we're done with that number here. But now we have these parentheses here. We're subtracting 2 from x before we actually do our logarithm. And that tells me we have a horizontal translation, and a subtraction has always been movement to the right. So we're moving this graph to the right by 2. All right, no more numbers there, so let's take a look at our third example. Our third example has no number in front, so we're going to move to the number inside being subtracted from x before we take the log, and that number is 3. So we have a horizontal shift, and because it's a subtract by 3, we are going to be moving to the right by 3. Now we're adding this number 4 to our logarithm afterwards. So we are affecting the y values. So we are moving our graph either up or down. And we know that if we add something, we will be moving our graph up by 4. And now our last example here is we do have a number in front. It's positive, so we have no reflection. But it is between 0 and 1, so we are compressing this graph by a half. Compressed by 1/2. The number inside our parentheses before we take our logarithm is +7. We're adding, so it's a horizontal left to right. We know from previous experience that if we add a number, we're actually moving to the left. So we're moving to the left by 7 here. And the subtraction on the outside tells me that we're moving vertical, either up or down. And here we're moving in a negative direction, so we're moving down by 3. And that's how we can take a look at our logarithmic equation and tell what kind of transformations are being applied.